Welcome to Public Health on Call, a podcast from the Johns Hopkins Bloomberg School of Public Health, where we bring evidence, experience, and perspective to make sense of today's leading health challenges. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes.
This is Lindsay Smith Rogers. We talk about climate change in general. Today, we're going to get more specific about what extremes look like. From heat domes to unprecedented rainfall and an ominous-looking hurricane season ahead, meteorologist Brian McNoldy, a senior research associate at the Rosenstiel School of Marine, Atmospheric, and Earth Science at the University of Miami, crunches complex data to make observations about extreme weather and how climate change is playing out. He talks about how all of the abnormal things we're seeing are actually becoming new norms and things we'll need to adapt to. Let's listen. Brian McNoldy, thank you so much for being here. And it's worth noting that we almost didn't have this conversation this morning. Can you tell us why?
Yes. Hello, Lindsay. Yeah, as it turns out, we had this on the books for a while, and little did we know at the time that we'd be having an extreme flood situation in Miami. And so, I wasn't sure even 12 hours ago if I would be hunting around for insurance claim items or being able to talk to you. So it was a close call.
But you are here. You did get a little bit of floodwater, and that is pretty much what we're going to talk about today is extreme weather happening in new and different places and what this all means. So first of all, let's talk generally about this phrase that's going around that 2023 was the hottest year on record. So what does that mean?
It actually was in a few ways of looking at it. So you look around the world, and as an average, the surface air temperature was a record warm. So, like where we live. And a lot of these weren't even close. Like they really broke the previous records by a pretty big margin. So in terms of surface air temperature, in terms of sea surface temperature, so, the topmost layer of the ocean. And then you can take the ocean temperature, and there's this quantity called the ocean heat content, which is kind of a measure of the heat in the ocean from the surface down through its depth. So there's a lot more oomph to that than just the sea surface temperature. And that was also a record high in 2023. When we look at those all in combination, it's really amazing, how warm 2023 was overall. So it's hard to pick any region that was completely responsible for that. A lot of the world as a whole all helped make that the case.
In your analysis of this, I believe you called it totally bonkers.
Yeah, somewhere around this time in 2023, I think probably this week in 2023, I wrote something along those lines in a tweet. It was related to global air temperatures and global sea surface temperatures, and they were just starting to drift so far above previous records. And I think I did use the phrase totally bonkers about that because I put it in the frame of even the people who look at this stuff all the time are amazed at it. When you're amazing to people who stare at it routinely, it's like, and it's starting to do things that they've never seen anything close to before, that's really quite amazing.
And you've already been talking about, what you've seen in terms of the 2024 hurricane season and some trends that you're looking at in the Atlantic. Can you talk about that?
I mean, we've already seen a few groups come out with their long-range forecast for the season as a whole, and they're all the most aggressive they've ever been. And so there's two big components that go into that at this early lead time. The season officially it started June 1st, but it doesn't really get going until August and then September and October. Those 3 months out of the 6 months of hurricane season, those three are really the meat of the season. So, now we're just a couple weeks into the official part of the season. And the two big environmental things that generally shape activity are whether there's an El Nino or La Nina or somewhere in between. And so we're rapidly transitioning from El Nino, which as of yesterday was declared over. So when you exit El Nino, you're then in neutral. territory. And then for a while, you're still in neutral. The tropical East Pacific Ocean, which is where this is measured from, when that becomes cooler than normal, that's a La Nina. And that's fully expected to happen by the peak of hurricane season. And so that ingredient, during El Niños, we generally see increased wind shear in the Atlantic. And so that reduces hurricane activity, all other things being equal. And then during La Nina, the opposite. You actually reduce vertical wind shear and enhance Atlantic hurricane activity. So we have that ingredient in the mix in 2024, La Nina, almost certainly. But then the other part that makes these long-range hurricane season outlooks so aggressive is the tropical Atlantic is warmer than it's ever been, even warmer than 2023, which we thought was insanely warm and just obliterated records. We're now breaking those records. So those two ingredients have never been observed before heading into the season. We've never had a La Nina with tropical Atlantic Ocean temperatures as warm as they are. So it's a bit of an unknown heading into it. We don't have any historical years to look back to and say, oh, this is what those years did. We don't have that.
Yeah, and it's interesting that you talk about the historical part of this, and we're going to talk in a minute about some examples of extreme weather outside of hurricanes. But, you hear these terms like 100-year storm, 500-year storm. We're kind of changing all of that, right? Like those don't really mean the same thing that they meant even 10 years ago, right?
Yeah, it's a tricky thing because, like our insurance costs are based on those sorts of numbers, like your odds of getting a flood and all that, like that totally goes into what insurance companies base their prices off of wherever you live, whether it's hurricanes or floods or wildfires, it all works the same. But with a changing climate, those climate stats of, what does a 1 in 500 year event mean? When you come up with those stats, it kind of assumes that the climate is somewhat the same as it was from the period that you used to create those stats. But when the climate is changing relatively quickly, you start to skew those. Maybe a good way to think of it is like a bell curve, where you have the wings way on the outside and then you have the big hump in the middle. And that big hump in the middle is the most likely thing to happen. And then the things way on the left and way on the right side of the wings are not impossible, but unlikely. So when you have a changing climate, you just kind of nudge that whole bell curve over. If we put it in terms of extreme floods, which is the thing on my mind this week, it's becoming more likely to get higher rainfall totals now than it was, let's say, 25 years ago. It still isn't likely to get 10 inches of rain in a day. We just did at my house, but it's becoming more likely.
There's an unpredictability factor, it seems like, in a lot of this. And here in Baltimore last week, we hunkered down in our basement for 45 minutes because we were watching tornadoes skip across our state. You are, seeing flooding that you've never seen before. People are seeing enormous hail. There is extreme heat in places that it wouldn't normally be that hot, and it's hotter for longer in places that might see some extreme heat from time to time. Like, all of this just feels very unpredictable. How can we look at data, and especially when it comes to public health, try to keep people safe, like have people pay attention a little bit more? They're not used to dealing with these kinds of extremes, and it's costing lives.
Yeah, and I think I'll pick on extreme heat as an example to dig into here. It's absolutely a trend that we're seeing here in Southeast Florida, but it's not just here, is the afternoon highs are gradually increasing, but much more of the signal is actually in the overnight lows. That trend is increasing at a much greater rate than the highs in places. So you're getting less of that nighttime and early morning break, basically, in extreme heat. And certainly if you think of places, well, like here, but I'm just using Southeast Florida as an example because extreme heat is definitely a concern for at least half the year, where even in the middle of the night and at 6 a.m, when it should be the coolest time of the day, the heat index, which is what it feels like to us when you combine the humidity and the air temperature, that can still be in the mid 80s to upper 80s at the coolest time of day. And it didn't used to be that way. So those morning trends are really trending upward. And it's a combination of the atmosphere being just more warm, so the air temperatures are higher. But with that, like a law of nature is that the atmosphere, when it warms, can also hold more moisture. So when we have a warmer atmosphere, it's also a more humid atmosphere. It's absolutely becoming a more adverse place for especially people without air conditioning. And people with air conditioning, it's just becoming a more expensive place to keep your place at a comfortable level. It affects people in that way too.
And air conditioning itself may be sort of contributing to climate change. It's like this perpetuating thing. So, in your work, you collect and track and you look at a lot of data. And as you've already said, the fact that you are thinking this is not good, that's alarming, right? And a lot of your work is about putting this data in a more accessible place. You're looking at these extremes. You're looking at this instability, this, we don't really know. It's unprecedented. What's going to happen? How can we use stuff like this to inform policy and to help keep people safe? How can we start to change a little bit to adapt to what's going on?
Well, I think by putting this information out to people, and I think a lot of people are generally receptive to information. I know there's exceptions, but increasing the awareness that these events are happening and they're not normal. It's inevitable. I mean, I see this every single day. Again, to use the most recent example here of the crazy rainfall and extreme flooding that we've just seen in a lot of places in Southeast Florida. And people will comment on things like, well, it's the rainy season. Yeah, you guys get storms. I'm like, well, there's no concept of outliers or like this was not normal. In no way was what just happened normal. And same with the extreme heat in 2023 that we saw. It's like, yes, it is normally hot and uncomfortable here in summer. This was way beyond that. I'll use the bell curve example as before. There's normal when you're in the middle of the hump, and then there's way out on the wing. And if you keep getting things way out on the wing, that's not normal.
And so what message do you hope that people kind of come away with out of the fact that this is not normal, but it is becoming normal?
Well, I think just being aware and recognizing it, and really at the ultimate part is this all goes up to the higher levels of who's running the county, the state, the country, that these things are important, and to put people there that can implement changes. That's about all we can do.
Well, I think it's very important, the work that you do. You are taking a lot of very complex data and you're putting it out there in an accessible way. And even just having you sum up a very long report by saying this is bonkers, it can really help us kind of understand, like, okay, this is not normal, but it is happening. Here we are. And, we have to start paying attention. Thank you so much, Brian McNoldy, for joining us. We really appreciate your time. And we hope that you don't see any major flooding in your house again.
Thank you. Yes.
Public Health on Call is a podcast from the Johns Hopkins Bloomberg School of Public Health, produced by Joshua Sharfstein, Lindsay Smith Rogers, Stephanie Desmond, and Grace Fernandez-Ciceri. Audio production by J.B. Arbogast, Holly Cardinale, Spencer Greer, Matthew Martin, and Philip Porter, with support from Chip Hickey. Distribution by Nick Moran. Production management by Catherine Ricardo. Social media run by Grace Fernandez-Ciceri. Analytics by Eliza Rosen. If you have questions or ideas for us, please send us an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes. Thank you for listening.